In this video, we're going to talk about phase diagrams. Phase diagrams are a type of graph that relate pressure and temperature to the state of matter for a given substance. And so this is a phase diagram. On the y-axis, we graph the pressure, and so pressure is increasing as we move up. And on the x-axis, we include temperature, and so temperature increases as we move from left to right. And there's a couple of interesting things that we can see with a phase diagram. We could tell the state of matter for a substance at a given temperature and pressure. So for example, this represents water, this phase diagram. And so on this graph, right about here would be standard atmospheric pressure, which would be 1 atmosphere or 101.3 kilopascals. And then right about here would be 0 degrees Celsius, and so that's the freezing point of water. Now if we connect these lines, we can see that they meet right about here, and if we look at the boundary, this is the boundary between the states of solid and liquid. So this line right here represents melting and freezing. So at 1 atmosphere, standard atmospheric pressure and 0 degrees Celsius, we could say that is the melting point and the freezing point of water. Now if we extended this line right here at 1 atmosphere out like this, we're going to get to another point here, and if we bring this line downwards towards the bottom, I think we can make a prediction as to what the temperature would be. We're on the line where a liquid is going to be turning into a gas, so we're going to cross this barrier, which means we're going to have boiling, and so this would have to be 100 degrees Celsius for water, because that's the temperature that water boils at. Now there's some other interesting things here. So we have these boundaries where we can have solid turning to liquid, liquid turning to gas. We can even have solid going straight to gas. We call that sublimation. We also have a point right here where all the different lines converge, and we call that the triple point. At the triple point, we actually get solid, liquid, and gas all existing at the exact same point. The triple point is a really amazing phenomenon, and it happens at a very low pressure and low temperature for water. So we're way down below atmospheric and a little bit less than freezing for water. And we would literally see some liquid water that was frozen on top, so some ice, and we'd see it bubbling away as it boils as well. There's one other point that we could see here, and this is called the critical point. At this point right here, we no longer have a liquid and a gas existing at the same point. So if you can imagine boiling water, like in this kettle right here, we can see that we have both states of matter. There's liquid water, and you would probably see the steam rising, which is that vapor, as the liquid turns into a gas. Now once we hit the critical point and we move out beyond this area, so if we're anywhere kind of in this region right here, we're going to have something called a supercritical fluid. And that supercritical substance is at the point where there's no longer a separation between liquid and gas. It just kind of becomes one thing. So it's kind of halfway between a liquid and a gas. So this is our phase diagram. That's some of the information we can gather from it. Some of the ways that we can change states include, number one, heating. Now this is probably the most common one. If you take some water and put it into a pan like this, put it on the burner, we're going to start raising the temperature. And so if we're sitting here with frozen water at this point and we just don't do anything to the pressure, we just start raising up that temperature, we'll eventually turn that substance into a liquid. Now we could also leave the temperature alone, so not adjust the temperature at all, and simply change the pressure. So here's an example of this. This is called a bell jar, this apparatus, where we have this plate here that have a bunch of holes in the top, and this jar, this glass jar that would fit over top, and we can create a vacuum inside that jar. So if we took a glass of water, put the bell jar on top, we have to attach here a vacuum. So we have this vacuum here that would start to suck out the air from this bell jar, lowering the pressure, so the pressure would decrease inside this jar. We could change this substance state without even touching the temperature. So maybe we're right here at standard pressure. You know, it's hot enough to be a liquid, this water inside this glass, and we slowly lower the pressure. We could eventually turn that substance into a gas and we could start boiling it without even changing the temperature. We'll take a look at one last comparison here. We have two different phase diagrams, one for H2O, water, and one for CO2, carbon dioxide. Each substance is going to have a different looking phase diagram based on its unique properties. So for water, we can have water changing from a solid to a liquid at standard pressure. So remember, this is 1 atmosphere, and we had right here 0 degrees Celsius. And so at that point, we can see it's going to melt, right? It's change from a solid to a liquid. With CO2, if we had 1 atmosphere of pressure, that's standard pressure, and we started heating up that CO2 at standard pressure, it would pass directly from a solid to a gas. And this is why, if you've ever seen CO2, another name for it is dry ice, you can see it just starts kind of giving off smoke. So you may have seen something like this before. This is dry ice that's subliming. It's turning straight from a solid into a gas, and we get all that different vapor there. So every substance has a different looking phase diagram, and you can change the state of a substance by changing the temperature or changing the pressure. And so those are phase diagrams.